See the problem related to arithmetic progression. Find the sum of first 24 terms of the list of numbers whose nth term is given by Tn is equal to 3 plus 2n. Here we have given the general term, that is nth term is equal to 3 plus 2n. By using this, first we have to formulate AP, then find the sum of 24 terms. We have given here Tn is equal to 3 plus 2n. Here by giving values to n, we should formulate the arithmetic progression. Find the first term, T1 is equal to 3 plus 2 into 1, that is equal to 5. And T2 is equal to 3 plus 2 into 2 is equal to 7. And T3 is equal to 3 plus 2 into 3 is equal to 9 and so on. Therefore, AP is 5, 7, 9 and so on. So, now we have to find the sum of first 24 terms of this arithmetic progression. Here, the first term A is equal to 5 and the common difference D is equal to 7 minus 5 is equal to 2 and which is also equal to 9 minus 7. Therefore, the difference throughout the progression is the same. Hence, it is an arithmetic progression, that is common difference is 2. Now, we have to find the sum of first 24 terms, that is S24. So, S24 is equal to, we use the formula to find the sum of first n terms of an AP, that is Sn is equal to n by 2 into 2a plus n minus 1 into d. Here n is 24 divided by 2 into 2 into a. A value is 5 plus n minus 1, that is 24 minus 1 into d. D value is 2. Now simplify this. 2 1s are 2, 2 12s are 24 into 2 5s are 10 plus 24 minus 1 is 23 into 2 is equal to 12 into 10 plus 23 plus 2 is 23 into 2 is 46, which is equal to 12 into 56. Therefore, this product 12 into 56 is 672. Therefore, the first sum of the first 24 terms of the formed arithmetic progression 5, 7, 9, etc. is 672. Now we see the next problem. Given the first term of an arithmetic progression, A is equal to 5, D is equal to 3. D is the common difference and the nth term Tn is equal to 50 is given. Now find n. N means the number of terms n and the sum to n terms of arithmetic progression. Now we try to find the answer to this question. So we have given here A is equal to 5. First term A is equal to 5, D is equal to 3 and the nth term is equal to 50. By starting from this given nth term is equal to 50, Tn is equal to 50. We use the formula Tn means A plus n minus 1 into D, that is equal to 50 given. A value is given as 5, substitute here, n is unknown and D value is given as 3, that is equal to 50. So simplify this. 5 plus 3 into n is 3n minus 3 into 1 is 3 is equal to 50. So 3n is the unknown term and 5 minus 3 is 2, that is equal to 50 minus 2. 2 is transposed to the right hand side, which become negative. Therefore 3n is equal to 50 minus 2 is 48. So n is equal to 48 divided by 3. So 3 1s are 3, 3 16s are 48. Therefore number of terms in the given arithmetic progression is 16. N is 16. Now find Sn. They said to find the Sn, not S16. So we have Sn is equal to, use the formula n by 2 into 2a plus n minus 1 into d. Substitute, n is unknown here because we have to find Sn only, not S16. That is 2 into a value is 5, substitute here, and n is unknown again, and d value is 3, which is equal to n by 2 into 2 into 5 is 10 plus 3 into n is 3n, 3 into minus 1 is minus 3, which is equal to n by 2 into 3n, 10 minus 3 is plus 7, that is equal to, therefore the Sn is equal to n into 3n plus 7 divided by 2. Now we see the next problem. How many terms of the AP, means arithmetic progression, 9, 17, 25 and so on, must be taken to give sum of 636. So what is given? Once again we read the question to understand this. How many terms of the AP? How many terms means here we need to find the n. Number of terms is always denoted by n. Therefore we need to find n here. How many terms of AP? 9, 17, 25. Arithmetic progression is given here. 9, 17, 25 and so on must be taken to give the sum of 636. For what number? For which number? For what number the sum is 636. So we have to calculate here number of terms. Here we try to find the answer here. That is, we have given the arithmetic progression is 9, 17, 25 and so on. Here the first term is 9. Common difference d is equal to 17 minus 9, that is 8. So 25 minus 17 is also 8, and we have given that Sn, sum of n terms. We don't know the number of particular terms of this given progression. Therefore sum of n terms is equal to 636 is given. So we have given Sn is equal to 636. Therefore we use the formula Sn is equal to n divided by 2 into 2a plus n minus 1 into d. So we have given this Sn is equal to 636, that is equal to 636. Now we substitute a and d in this formula. Therefore that is n is unknown here, n divided by 2 into 2 into a value is 9, n is unknown again, and d value is 8, that is equal to 636. Now transpose this 2 to the right hand side, which will be multiplied with 636. Therefore n into 9 2s are 18 plus 8 into n is 8n minus 8 into 1 is 8, that is equal to 636 into 2. Here also we multiply. N into 8n is 8n square. 18 minus 8 is 10. 10 into n is 10n is equal to 636 into 2 is 1272. Now transpose this 1272 to the left hand side. Therefore we get 8n square plus 10n minus 1272. Right hand side nothing is remaining, means it is equal to 0. Now we can also see here 8 is even number, 10 is even number, 1272 is also even number. Therefore here 2 is common. 2 into 4n square plus 5n minus again here remaining is 636, that is equal to 0. Now transpose again 2 to the right hand side. 0 by any number is equal to 0. Therefore we have remaining here 4n square plus 5n minus 636 is equal to 0. This 4n square plus 5n minus 636 is equal to 0 is a quadratic equation. Now we have to find the value of n by factorizing this quadratic equation. So how to factorize this? Splitting the middle term. Now the product we have to find the coefficient of the higher degree term, that is a 4, and the constant term, that is 4 into minus 636, that is equal to minus 2544. Now we need to find all the prime factors of this 2544 by the method of prime factorization method, and by adjusting some factors we will get one is 53 and next 48. This product is 2544, but we want the negative sign, therefore we want the product should be negative and the sum should be positive. If we want the sum is positive, then the greater number we can take a positive and the smaller one is negative. Therefore the two factors of 2544 is 53 and 44. Therefore we can rewrite here 4n square plus first we here we write minus 48 because 4 is common in 48. For minus 48n plus 53n minus 636 is equal to 0. So we group the terms. Here 4 is common and one n is common, remaining n minus 4 1s 4 2s n minus 12 plus here 53 is common, then remaining n minus 12, that is equal to 0. Now grouping the term, that is n minus 12 into 4n plus 53 is equal to 0. In this product either n minus 12 is equal to 0 or 4n plus 53 is equal to 0, but not both equal to 0. Therefore n is equal to 12 or n is equal to minus 53 divided by 4. But in this chapter number of terms are always positives, therefore n should be positive. So number of terms n is equal to 12 only. So the sum of 12 terms of the given AP is 636. The next problem, the first term of an AP is 5, the last term is 45. Here it is given the last term is 45 and the sum is 400. Find the number of terms. Here once again we have to find the number of terms n and the common difference d. So we try to find the answer here. Answer, first whatever given we list here. First term of an AP is 5, means A is equal to 5. The last term is denoted by L and it is also the nth term, that is equal to Tn also we refer, that is equal to 45, and the sum of n terms, sum to n terms is equal to 400 is given. We have to find the value of n, means number of terms is how much, and also the common difference d is equal to how much. When the last term is given, then we use Sn is equal to n by 2 into a plus l formula. So here we have Sn is 400, that is given. The sum of n terms of an arithmetic progression is 400 and n is unknown here, into the first term is 5 is given and the last term is 45 is given. Therefore we have 400 is equal to n by 2 into 5 plus 45 is 50. Therefore we have n is equal to 400 and this 2 transposed to left hand side, which is multiplied by 400 and 50 will be divides. Therefore here 50 ones are and 58 400. So n is equal to 8 2 16 terms are there. Therefore the value of n here, number of terms in the given arithmetic progression is 16. Now we have to find the common difference. How do we find the common difference? We use the nth term. We have given the last term is denoted by Tn, that is equal to 45. Therefore we use the Tn formula, which is a plus n minus 1 into d is equal to 45 is given. Substitute the value of a, n. A is 5, that is the first term. N is just obtained, that is 16 minus 1 into d is equal to 45. Therefore 5 plus 16 minus 1 is 15, d is equal to 45. Transpose this 5 to the right hand side, which is subtracted from 45. Then 15d is equal to 40. Therefore d is equal to 40 divided by 15. Hence we divide 5 3s are 15 and 5 8s are. Therefore the common difference in this case is 8 by 3. The common difference may be negative, 0 or fraction also. No problem here. Therefore the common difference d is equal to 8 by 3 and the number of terms in the given progression, arithmetic progression, n is equal to 16. Next problem, find the sum of first 22 terms of the AP in which common difference d is equal to 7 and 22nd term is 149. Here first understand the question very clearly. 2 times 22 is given. Find the sum of first 22 terms. Here the question is clear. Find the sum of first 22 terms of an AP and also given the 22nd term is 149 and the common difference d is given. So try to find the answer. So here we have given that d, common difference d is equal to 7 is given and the 22nd term is always t22 is equal to 149. Now we have to find the sum of first 22 terms, that is s22 is equal to how much. First we have given t22 is equal to 149. This we use t22 is equal to 149. Use the formula Tn is equal to a plus n minus 1 into d, that is a plus n is 22 minus 1 into d value is 7, that is equal to 149. Therefore a plus 22 minus 1 is 21 into 7 is equal to 149. Therefore a plus this product will be 7 1s are 7, 7 2s are 14, which is 147, that is equal to 149. So a is equal to 149 minus 147. So 149 minus 147 is equal to 2. Therefore the value of a is equal to 2. Now we have to find the 22nd term, that is s22. s22 is equal to, we use the formula here Sn formula, n by 2 into 2a plus n minus 1 into d. So n is here 22 divided by 2 into 2 into a is 2 just obtained here plus n minus 1, that is 22 minus 1 into d is given as 7, that is equal to 2 1s are 2, 2 11s are 22, 2 2s are 4, 22 minus 1 is again 21 into 7, that is equal to 11 into 4 plus, already we have find the product of this 7 into 21, that is 147, which is equal to 11 into 147 plus 4 is 151. Therefore this product is equal to 11 1s are 11, 1 carry, 11 5s are 55 plus 1 is 56, 5 carry, 11 1s are 11 plus 5 is 16. Therefore the sum of first 22 terms of the given arithmetic progression is 1661. See the next problem and the important one. The sum of 3 numbers in an AP is 27 and their product, whatever the 3 numbers are in AP, their sum is 27 and the same numbers, the product is 405. Find the numbers. How can we find what are the 3 numbers? when this type of problems or statements are given in the question, then we consider the general form of an arithmetic progression, that is a plus d, a plus 2d, a plus 3d, etc. Also the left hand side of general form is a minus d, a minus 2d, a minus 3d, etc. So let the three numbers, whenever there is given the three numbers are in AP, then we can take, let the three numbers are a minus d, a and a plus d. When the four numbers are in AP is given, you remember that you can take, it is a minus 3d, a minus d, a plus d and a plus 3d. Here three numbers are given, therefore we take a minus d, a and a plus d are the three numbers in AP. What is given? Their sum is equal to 27. That means a minus d plus a plus d is equal to 27. Here d and d are getting cancelled. A plus a is 3a, which is equal to 27. Therefore a value is equal to 27 divided by 3, that is equal to 9. Therefore the first term of an three numbers, that is a, is equal to 9. Next it is also given that their product is equal to 405. Their product is equal to 405. That means a minus d into a plus d is equal to 405. Now we already know the value of a, that is equal to 9. Substitute here, that is 9 minus d into 9 plus d is equal to 405. Transpose this 9 to the right hand side, then remaining here 9 minus d into 9 plus d, and it is of the form a plus b into a minus b form, that is equal to a square minus b square. So 9 minus d into 9 plus d is 9 square minus d square, that is equal to 405 divided by 9. Simplify this. 9 ones are 9, 9 fours are 36, 4 carry 45, 9 fives are 45. So this is equal to 45. That is 9 square is 81 minus d square is equal to 45. Now d square is equal to 81 minus 45, which is equal to 36. 81 minus 45 is 36. Therefore d is equal to plus or minus square root of 36, that is equal to plus or minus 6. So when a is equal to 9, d is equal to 6, the numbers are a minus d, that is 9 minus 6 is 5. Next a, that is 9. Next a plus d, which is 9 plus 6 is 15. And also when a is equal to 9, d is equal to minus 6, you will get the reverse order of this number. Then the numbers are 15, 9 and 5. Therefore the three numbers of AP are 5, 9 and 15.